So in the last process we got all those products which we want to recommend, the top list of products which we want to recommend. Now once we have this top list of products, the next process is to update all our dictionaries based on the products which we've got. So there are two scenarios here. If that state ID exists, then obviously all our dictionaries has got those state IDs, and then we need to update it. Now say for example, if the state ID do not exist, then your previous dictionaries do not have that state ID. Then we have to add those the state IDs, specific state IDs into the dictionaries, and then add those products. So that will be a separate function which we will discuss after this. But first we will discuss the scenario when the state ID exists. So this is the function which is used for it. So your product list, this is the product which recommended products which we've generated in the earlier process. That's the product list. What is your state ID? And then your different dictionaries which you want to update: count dictionary, recommendation count dictionary, and is your value dictionary, which is a policy dictionary, and your reward dictionary. These are the dictionaries which we want to update. So what we do is, inside the function we have an iterative loop to run through all those products which have been recommended. Now if there are 10 products which we are going to recommend, so we have an iterative loop for all these 10 products. So first we update the count dictionaries, the dictionary which counts the number of products which are there. So if the product in that count dictionary, because the count dictionary state ID and the keys will give you the inner keys, state ID will give you a inner dictionary, and that inner dictionary's keys are your product, the product stock code. So if those if the product which you have already bought in this list is already there in that dictionary, then we update that count by 1. Okay, we increment that count by 1, because this is the quantities which is this is the frequency, the number of times that product is bought. So we update it by 1 because we have already recommended it, or we have already taken the product. Otherwise, if it is not there, then what we do is we don't if that specific product is not there, we just update it as the first product if it is not there. Similarly for a recommendation count. Now if the product is in that list of the recommended count of products, then we update it by 1. If that product was not there, then the first value it's as 1. So these are the updates which we've got. Now other thing which we have to update is the policy dictionary and reward dictionary. We don't do the update here right now. We'll do later on once the value function is there. That we'll see later on. But here what we are doing is, if that product is not there in the policy dictionary and the reward dictionary, then we need to initialize a value for the product, because that product was never been bought, and we are recommending this product based on our top products for that state ID. So such scenarios occur when usually when we during that sampling process, that SciGreedy sampling process, if that product is not there as part of the state ID, then these products get added to it. Now the basic premise is it is not in recommendation engines there is this premise for serendipity, that is your surprise element. So it's not that you always recommend products which are more popular. Maybe we'll try on a need by need basis. We also recommend products to give a surprise element, because we don't know whether this will be appealing to a customer or not. So this is why we give this serendipity, and this the whole process of the SciGreedy is being implemented here. So for those specific instances when the product is not as part of the state ID, that's when this can happen, this scenario can happen. And so in that case we'll have to initialize these values as 0, because we have never seen this product being bought for that product. So we initialize this as 0, the value, and the reward, we take it as a Gaussian process. We generate it with mean value of 0, and we generate a Gaussian process. So we return all those dictionaries back in the function. So this is the function. We'll see its implementation later on. So now we'll get into the function for adding these products, or when the state ID do not exist. So earlier we saw when how you update it, because update case is when the state ID exists for those dictionaries. But if the state ID never exists for those recommended list of products, then we have to add these specific state IDs and the products for which we are recommending for those specific state IDs. So the first process is to create those state IDs for those 4 dictionaries, and then create this inner dictionaries. Now inner dictionaries is where we store the list of products according to the stock code of the product, and the quantities are stored in the inner dictionaries as keys and values. Again, similarly, we just iterate through all those product lists. These are the list of products which we are recommending, and we just initialize it to 1. Say the count is initialized as 1, and the value function is initialized as 0. The number of recommended products, number of times the product is recommended as is initialized as again 1, and then the reward is again through a Gaussian process with mean value of 0, because it's the first time it's been generated. We generate a reward function for this. So, and then we return, similar to the update function, we return all these values back to the calling function. Now we'll see these implementation, these calling functions, and how these implemented in the next code block. So far we were seeing these different functions which were used in the whole recommendation process. So we have seen all of those products, all of these functions to recommend products, functions to update the dictionaries, add these dictionaries, etc. Now we'll use those functions to initiate our recommendation process. Now these are now you have seen all those functions. Now these are just a few lines of code which we have. So here first we define the number of products which we want to recommend. So it could be 10 or 5 or whatever you want. You can fix that, and epsilon values also, as a hyperparameter we give. Now the first thing is, as you said, as we discussed, there are 2 processes. One is to update and add. Now if the state ID exists, then you update the dictionaries. If the state ID do not exist, you add the dictionaries. So the check for that is to check whether my policy dictionaries which we initialize in the beginning. So this is the line. Let's go forward, or upward rather. So if you look at this line, we generated this my policy dictionary during our initialization process. My policy dictionary is the dictionary with the stated. So the number of it gives you the list of only the products and the counts. So this line means that if the mypol dictionary is greater than 0, that means that context already exists, and there are some certain products in that which has already been recommended in the product, or which has been already been bought under the state ID. So if this is greater than 0, that means that context already exists, that is the state ID already exists. Then we implement this sampling products, which gives you the total top 10 recommended products, which is, so we saw that earlier. And then based on these products which we got, we have to update all those dictionaries, and we return these dictionaries as updated dictionaries as is returned. So if the value of this whole dictionary is 0, that means that context was never seen before. Then again what we do is, so there was no product at all, there are no top products, there is no case. So here what we do is we randomly sample the 10 products which we want, because this state ID doesn't exist, so we just randomly sampling the top products from this from this products, and then we update this, add these values into a dictionary. So these are our simple ways in which we segment products or recommend products, get the recommended products, and then update our dictionaries. So far we have implemented all the recommendation process and then updation process. Now next is our feedback process, which is based on the customer actions. We are recommending some products, and then the customer is now going to decide, is going to give you the feedback. So the environment is giving you the feedback, whether the products which we have recommended is good enough or not. So, and that is the basis of our self-learning, because based on whether the customer, so the feedback is based on if the products are good, appealing to the customer, the customer will buy it, or the customer is little interested, maybe the customer will browse through the products, otherwise the customer will just ignore it. So these are the rewards which you get, and how these rewards are used for updating these values, and that's the basis of a self-learning part. So next we will look at the self-learning part of our recommendation systems.